You guys sound like I feel. How many of you were geeking out very late last night? Yeah. How many of you are geeking out last night to Star Wars? How many people are excited about the upcoming movie? Yeah, a couple of hands. How many people? Yeah, okay, there we go. So, how many people are convinced J.J. Abrams is going to fuck it up? That is the triumph of hope over experience right there, because everyone's like, no, it won't get screwed up this time. Did you ever go back and watch the original films and then realize that they're not anywhere near as good as you remember them being as a small child? History has kind of a funny way of doing that to people. My name is Ted Neward. This is me. I've been doing a lot of things in a lot of different platforms, actually. I spent a significant amount of time in the Java space, still do, as a matter of fact, and wrote a couple of books there. I've spent a lot of time in the .NET space. Most recently, I've been kind of an F# guy. I will promise not to try to, convince you of the goodness of functional programming. We'll save that for next year's NSBCon. This is all to get a hold of me if you choose to. But the interesting thing is I've been around for a while. I've been doing a lot of this programming stuff for, some number of years. And if you've been here for any length of time, you begin to realize that for some reason we keep seeming to making the same mistakes all over again, right? I mean, how many of you have been programming for more than 10 years? Show of hands. Yeah, that's what I expected. How many have been doing it for more than 15 years? Show of hands. More than 20 years? More than 30 years? More than 40 years? That's not programming, that's just punch cards? Is that what you said? Wow, way to piss off the guy who wrote the code that cashes your paycheck, dude. Think about that next time before you open your mouth. Normally that's my job. One of the things is we keep doing these various things. We keep making some of these mistakes over and over and over again. And I keep wanting to figure out why we keep doing this. I mean, some of the stuff that we've done, some of the things that we've done, they were, kind of excusable because we didn't know any better. We just didn't understand what we were trying to accomplish. And quite frankly, I'll hold up as an example the very early attempts at doing things on the web. For a lot of programmers, this was really the first time that any of us really got into any sort of user interface design. And a lot of those early attempts at trying to create something that people would be interested in and excited by and feel kind of jazzed about and so forth, a lot of those attempts didn't come off so well. Since most of you put your hands up for more than 10 years, most of you will therefore remember the movie Space Jam, right? The Michael Jordan Looney Tunes crossover flick. Did you know that the Space Jam website is still up? Yeah, for those of you who haven't, just because this is good periodically to kind of revisit where we came from. Hang on, I gotta stop PowerPoint here to let's see, end show here real quick. Flip over to Chrome. Best Chrome extension ever. This one. Star Wars, yeah. So if we say Space Jam, and then sure enough, it's the first link. Isn't this hideous? This is so cool. It's hideous. I mean, check this out, right? Let's look at the Pressbox shuttle, right? No Space Jam news. How about the lineup? Oh, check it out, Frames, right? Frames is cool, right? And let's see, Junior Jam with the client side, image map, right? So we'll have different links based on where we were, and of course we're back to the frames. Of course, the frames are in a different place now. Right? We got the little spinning jiffy thingy down here, right? The only thing that would make this thing better is if we had like flames somewhere, right? I'm pretty sure we got flames here somewhere. Copyright 1996. This is the era in which we thought the blink tag was cool. and the marquee tag, right? This is what you pull up anytime you as a developer want to get out of doing UI. You just point your boss at this and say, boss, I built stuff like this. Do you really want to give me the keys to that particular kingdom all over again, right? And okay, you know, it was an interesting experiment. It was a good experiment from the standpoint that for most of us, I mean, you certainly had done some GUI programming in the past, right? If you were a programmer in the years prior to that, you figured out where to put text boxes and buttons and all of that stuff. But it was usually in the context of a larger application that was designed by somebody else. You didn't necessarily design everything the same way. HTML released this sense of developers can now start building UI, and we did, and discovered that that's what we come up with if we do. And we learned a lot from it, to be very blunt. We learned a lot about how the web works, how the web is supposed to work. We learned a lot about how UI is supposed to work. So I would argue that, yeah, I mean, certainly I wouldn't want to go back to that style of UI, but at the same time, we learned a great deal from it. And if you look at what we've got today, it looks a lot cleaner. It looks a lot better. Not just stylistically, because we'll go through certain UI fashion trends the same way as anything else does. But there are other things that we've gone through that really just seem to be repeats on the thing before, and that whatever's different may not be a whole lot different. And if you listen to some of the comments, some of the things that people say about these things, they tend to get kind of blurry, right? Why isn't software more like hardware? Why must every new development start from scratch? There should be catalogs of software modules. When we build a new system, we should be ordering components from these catalogs and combining them rather than reinventing the wheel every time. We would write less software, right? Then the problems everyone laments, the high costs, overruns, lack of reliability, just go away. Who wouldn't sign up for that? Or we've got fast-moving and demanding world of e-commerce and information technology has put a new kind of pressure on application developers. They have to be designed, built, and produced for less money. To reduce costs and fast-track enterprise application design and development, Thing provides component-based approach to the design, development, assembly, and deployment of enterprise applications. Who doesn't want some of that? Or the 3 standard and most common business drivers for any particular architecture are the ability to respond to business needs, improve customer experience, reduce the cost to add more products. Seriously, who doesn't want this? Who does not want actually to reduce costs? Who wants to be more expensive than they were the day before? Show of hands. Right? Yeah, consultants, right? Yeah, consultants. That's why my hand is up. Yep, yep. Who does not want to improve the customer experience? I like the Space Jam website. I'll just admit it now, right? These are all these, it kind of feels like every time a new technology comes out, we reach for the same reasons as the technology before it. This will improve reusability. This will improve customer experience. This will reduce cost. This will improve. It's always the same tired old phrases. Case in point, these 3 quotes, they came from a primer on SOA, a primer on REST. I'm sorry, no, it was a primer on J2EE, and it was a primer on objects. And if we had access to the books that were being published around, say, 1980, when structured programming was just becoming a thing, we would find almost exactly the same paragraphs. We just can't seem to actually deliver on some of these particular promises. Because the truth of it is, these are the same things that we've been trying to do since 1950. Ever since we first started getting to the point where computers were more standardized and we could start creating tools and languages and start selling them to people. I mean, heck, you could use those paragraphs to describe why we went to computers in the first place. You go all the way back to like the late 70s and early 80s, right? Computers themselves were supposed to reduce costs and improve experience and allow the business to be more agile and nimble, because now even you could have a spreadsheet on your desktop. And I mean like the physical desk, not the virtual one, right? That was power. And we got into doing procedural programming, we got into transactional processing, we got into objects, and then later we extended the objects across the wire and called them distributed objects, Corba and DCOM and some of that ilk. We got into some of the dynamic languages. I remember very clearly Dave Thomas, Ruby Dave as he's called today, standing up in front of people and showing them Rails, and everybody going, oh my gosh, and the Rails community, oh yeah, you can be like 500% more productive, and this code is all scaffolding. It's a DSL for building web applications. And everyone went, yay. Now we're talking about functional languages like F#, we're talking about services, we're talking about REST, we're talking about enterprise service bus, we're talking about all these different things. And you know, part of me just says, I keep seeing, we keep doing these things, and you could argue that maybe we learn something different each time, but at the same time, these guys sometimes argue with each other. You go to some of the various functional language space, and these people will tell you that the object-orienting era has been a dark ages from which we are only now beginning to emerge. That languages that are not constructed off of a mathematical basis just were simply a mistake. Or the dynamic languages guys saying, look, you need to have the power. You need to have the ability to just force the language to do what you want it to do. Whereas the static folks will say, no. You need a tool to verify because you're human and you make mistakes and we need static type systems. And we keep arguing at each other about which one will actually lead us back to those things. And yet, we don't ever really seem to solve those basic problems. We don't ever seem to get to that level of IT agility and reduced costs and all that other good stuff, except occasionally we do. Occasionally we do get back to some of this stuff, right? And occasionally we actually are successful, but it doesn't seem to be happening with any great repetition and certainly with no great degree of predictability. And it's not that there isn't some good analysis here. It's not that there isn't some good ideas. Right? Talk about SOA for a second here. If we get into the whole service-oriented space, and you know, if you've been following UDI for a while, you've probably heard the discussion around the 4 tenets of SOA, right? Services, just to kind of level set. Style of architecture, focused principally on services. Architectural approach to creating systems built from autonomous services. Integration becomes forethought rather than afterthought. That's not a bad idea. That's not actually a terrible idea to think about how we're going to integrate some of these things in the beginning rather than as an afterthought. Because as much as, for example, the Java guys really wanted to believe that the entire world would somehow unify behind this programming language that allowed you to write the code in one place and run it anywhere, it didn't happen. And I would stand here and submit to you that it never will happen. Ever since the second computer manufacturer came online and started producing these things, ever since the great IBM-Apple rivalry of the 1980s, we're never going to see a point where one language, one platform, one whatever dominates. So this idea of actually embracing the fact that integration is going to be a fact of life, that's not a terrible thing, right? And a bunch of the SOA stuff, you could argue, got derailed by the fact that we really got, you know, neck deep into all of this XML stuff and all of this XML implementation, and we got like bazillions of standards. And the result was it didn't save anything, but it had a number of good ideas. And the idea of standards is not a bad thing because, you know, let's be honest, standards are what allow us to be able to talk together. If we're going to focus on integration, then yeah, we need to have some of those standards in place. We keep making a bunch of these mistakes, and if we think about the whole industry, what we deal with in sort of the classic, you know, people, process, and technology, in some respects it feels like we keep expecting too much out of the technology. We keep standing these things up and saying, this will now solve all of our problems. Today's target, today's discussion, right? REST. Everybody loves REST. REST is amazing. REST is just beautiful. REST is the way the web was supposed to work. REST is the silver bullet. As long as you have REST in your pocket, you can be successful. That really seems to be the message. And has anybody ever stopped to wonder, right? HTTP has been around since, was it 1996? Well, we were just misusing it. We were somehow abusing the technology back, particularly because we were using HTTP as part of all of that SOA, right? SOAP over HTTP, because HTTP knows that it's got SOAP and so it fails, and yeah, but now REST will solve all of our problems. REST is the silver bullet. Kind of wonder maybe if it's not going to be the technology or Agile. Yeah, you guys don't like it when I make fun of SOA, but if I make fun of Agile, you're like, yes, I'm on board with that. Yes, all those hipster Agile coaches who go around telling you to embrace your feelings, right? Yeah, let's make fun of those guys. The SOA stuff's a little too close to home, dude, but the Agile guys, we can make fun of those guys. That's safe. Right? Kind of like if I'm in Washington, it's really, really safe to make fun of Republicans. When in Texas, however, we keep making these same mistakes. There's this amazing quote. Many of you have heard it, right? George Santayana is a historian. Santayana syndrome is those who cannot remember the past are condemned to repeat it. And then we turn around and look at all these 20-something hipsters in San Francisco who are producing all of these single-page application frameworks and saying, please save us from ourselves. And if you've been around, you've been through a couple of those cycles where we turned to the 20-somethings in the Ruby community and said, please save ourselves. And then we turned to the object designers, right? And said, please save us from ourselves. And the transaction processing monitor designers, please save us from ourselves. Maybe at a certain point, we just got to save ourselves. Maybe. We keep making these same basic mistakes. And there's certainly technological mistakes. You all got a copy, right, of the fallacies of distributed computing when you checked in here. All right, well, when I wrote the book, Effective Enterprise Java, back in 2004, I actually, in my arrogance, added 2 more fallacies, and I changed the title slightly. The fallacies of enterprise computing. The 2 that I added, number 9, the system is monolithic. The system is one big ball of mud, and we will continue to release and revise and change, and if I do in fact release a new thing, everybody's on board. This is the thing that brought Corba and DCOM to its knees, because in the beginning, we build a system and we all agree on the interfaces, right? We all agree on the fact that, yes, we're going to have these object types, and they're going to take 2 ints and a string, and they're going to be in this particular order, and everybody's on board, and we distribute those interfaces to everybody to go and generate some code based off of those interfaces, and it's all wonderful and magical for V1. And then one of the guys sitting in the room one day turns to the other guy who's built the server implementation of these objects and says, hey, by the way, you remember that method that we take 2 ints and a string? I actually need one of those ints to be a float instead. That seems like a pretty reasonable thing. I mean, it's a backwards compatible change, right? Before, we didn't have a 0.0 that would be following those integers. Now we just have to account for the fact that there will be a floating point component to it. That really should not be all that hard. Except now what I have to do is I got to get everybody that was in that room before together in that room again to agree that, yes, it's safe to go to a V2. And folks, that's not really a technical problem. That's a political problem. That's a people problem. I now have to grab a group of people that I don't have any direct influence over. I have to go get my partners. I have to go get my other businesses. I have to go get the other departments. I have to gather them all in a room and say, by the way, in order to accommodate a change that most of you don't care about, all of you will have to take a hit to your productivity to, at the very least, grab those stubs and recompile. And oh, by the way, change all of the client code that uses those stubs that changed. You're all on board with that, right? right? You guys are cool with that. Some random stranger out of nowhere calls you and says, by the way, your project is about to break unless you show up in this room at this time and agree to things that you don't care about. That sounds more like a hostage situation to me. The other fallacy that I added, the system is finished. Do you know what a finished enterprise system looks like? Nothing. It doesn't exist anymore. There are still enterprise systems from 1960 that continue to be evolved because the bank built all of their processing around the manner in which these transactions are being processed. The only time an enterprise system is ever finished is when the last server is powered down, the source code is deleted, and the programmers that worked on it are all taken out into the street and shot. Because if you don't do all of these things, it will come back like some hideous, ugly form of the phoenix, sort of the anti-phoenix. You want to kill it, and it just refuses to die. No enterprise system is ever finished. And so we have to consider the fact that we're going to continue to evolve this thing over time. So it's really easy to stand up in many ways and say, look at all the things that are wrong, blah, 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 right? I mean, that's basically what political pundits do pretty much every day of the week, particularly during election season, right? Everything is broken, and if you elect me, it will all be fixed, right? So if you all elect me, king of computer science, then I can just wave my hands and I will, give, good jobs to everybody, and everybody gets a pony, right? Who's on board for that? Who wants a pony? Yeah, there you go. Vote for Ted, 2016. Yeah, part of the thing though is if you're gonna stand up here and you're gonna poke at things, then you also gotta be willing to say, all right, so if stuff is broken, here's how we go and fix it. And by fixing it in particular, we can't throw away the things that we have found that are good, right? This is one of the things I think that we lose track of periodically. I think implicitly people try to do this, but explicitly we don't really acknowledge some of the stuff that came before that we do in fact want to keep. So for example, in the original procedural programming, right, the idea that we had structured entry and exit points, the fact that we had some data structures that we could all kind of agree on and work with, I mean, for many of us, that was just fundamental because that stuff was already in place when we got started programming. Some of you remember the structured, programming craze when it came around, and wow, this means I don't have to write code in assembly anymore. That's a good thing. One of the arguments for the C language is it was a portable assembly language. We lose track of that sometimes. And then when we got to objects, we didn't say, yeah, all those procedures, throw them away. Nobody likes procedures. Procedures are just, bleh. Right? We kept them, and then we gave them a new name, because that's one of the things you have to do. When the new regime steps in, you've got to immediately rename all of the old stuff so people don't remember the old regime. It's just all the new stuff. So now they're methods, right? But a method is basically a function, but with an additional pointer floating around in space somewhere, the this pointer. But you don't need to worry about it unless you want to worry about it. And the thing that objects gave us was this concept that state and behavior around a closely related concept should be unioned. They should be brought together into one thing, into one place, which we call the class or the object or what have you. And one of the things that the object guys, particularly Alan Kay, right? This is the guy who invented Smalltalk. Alan Kay has this great quote. He says, I invented the term object-oriented, and I can tell you C++ was not what I had in mind. Yeah, it's kind of a funny quote. What does he really mean by that? Well, in particular, he doesn't actually like procedures. He likes messages, right? If you go back and learn Smalltalk, the way in which Smalltalk works is these objects communicate by sending messages to each other. And okay, well, people took that and took that across the network as well to do messaging across the network. I mean, fundamentally, if you really want to break it down, TCP/IP is messages flying back and forth with acknowledgments, et cetera. But if we talk about messaging the way most of us think about it, There's this concept of a destination where I want to send the messages to. There's this concept of a runtime that helps manage the delivery of the messages and so forth. All of these things that have come along the way, even REST, even when it's fun to point at REST and say, you hipster idiots. There's a lot of good ideas around REST. The idea that it's a limited verb vocabulary. One of the things that's kind of interesting is REST sort of turns some of the discussion around a little bit, which says normally we think about a fairly limited set of nouns and then a huge set of verbs that are each unique to those nouns. So person has a bunch of things that a person can do. REST flips it and says, no, there's only 4 verbs in the world, right? There's only get, post, put, delete. That's it. That's all you really need. And everything else is about resources and representations, and that's not something we really want to lose track of. And SOA, right? One of the things that I liked about SOA was the 4 tenets. Boundaries are explicit, service is autonomous, share schema and contract, not class, service compatibility based on policy. These are good things. There are a lot of things in here that are deliberately designed to help us avoid the fallacies, right? Boundaries are explicit. Yesterday, as we were sitting in here and watching the ACA session, right, he talked about location transparency. The idea that I shouldn't have to know where that server is, right? That's part of the reason domain name service exists. Most of us don't want to try to remember IP addresses in their 4-dotted numerical form. That's just a little bit more than the human mind can keep track of easily. This is part of the reason why some of us can't even remember our own phone numbers, because you've programmed it into your phone once, and then from that point forward, you just scroll. Oh yeah, there's wife. Okay, hey honey. And if you actually ask what is your wife's mobile phone number, the only reason I can remember my wife's mobile phone and my eldest's mobile phone is because they happen to be sequential. So my phone, her phone is 4524, my eldest is 4525, mine is 4526. My youngest, I have no fucking clue, because we got his phone later, right? So we didn't get the nice sequential number, right? We don't remember numbers particularly well. We like names. Names are good, right? www.evilhacker.org. That's a pretty rememberable name, right? But one of the things that I think we lose track of when we start talking about location transparency is we do, in fact, want to differentiate between local and remote. This was something that never came up during the DNS debate, right? When we talk about domain name service, okay, whether it's 192.68.42.12 or whether it's www.newardassociates.com, those both referred to the same thing, but there was never this notion of that somehow that might be local. That was always called localhost, or I just didn't touch the network at all. It was very explicit that you were leaving the local machine. Then for a while, as people started talking about distributed objects, is where I first picked up on it, people said, yeah, you don't have to worry about where it is on the network. You don't even have to know whether it's remote, right? So this is basically the argument that if I want to talk to any of you, all I have to do is pull out my phone and dial, because the phone is the preferred medium of communication, even if we're standing face to face. And that just doesn't make a whole lot of sense, does it? Now, if one of you is in your office and the other is in the bathroom upstairs and you need toilet paper, totally different story. Totally different story, right? But this notion of location transparency was never supposed to mean I don't care whether it's local or remote. It was only supposed to mean I don't care where it was remotely. And the services guys picked up on this and said, look, you know that you're coming to a boundary. You know when you're crossing a fence. Good fences make good neighbors, says Don Box when he first starts introducing the thing that would later become to be known as WCF. Knowing where those boundaries are, because then we can actually start to know when I'm making a long distance trip, right? There's a big difference between walking out to the mailbox and getting in your car and driving to California. I know where those boundaries are. I know when I'm about to do this long haul travel. And that's important for performance reasons, for all the fallacy reasons, for the fact that the network is not reliable, so I might get lost along the way. et cetera, et cetera, et cetera. Boundaries are explicit. That's a good thing. Services are autonomous. One of the things that we got kind of wrapped up in during the whole distributed object craze is, oh, I got all these objects. And I kid you not, during the whole DO thing, Corba and DCOM and so forth, there was kind of this idea that said, if I've got all these objects here, if I just scatter them across the network, location transparency, remember, if I just scatter them across the network, it'll all just work. And this is where we started talking last night on the panel about, okay, well, 99% uptime on that object times 99% on this object times this object times this object times this object. Every time you add a new object that you depend on, your overall reliability rate drops just that little bit each time. And quite frankly, if you actually go through and do the calculations on a calculator, you realize it doesn't take too many dependencies before 99% uptime really starts to drop off. And you start running into, yeah, so now only 50% uptime, only 1 in every 2 sequences is ever going to actually work. So yes, we definitely want the idea that these things should in fact stand on their own, that they should deploy and they should version and they should somehow be independent of all these other things. That's a good plan, that's a good idea. And we shouldn't rely on particular details that will in fact trip us up later, right? We should design these things to be contracts between each other, but they shouldn't rely on any particular implementation detail around, for example, what's the size of an int, right? Is anybody old enough to remember a time when bytes weren't always 8 bits? There was a time, there was a series of hardware computing platforms before the PC era where people could not actually agree on the size of a byte. To some manufacturers it was 7 bits, to some it was 8 bits, and to some it was 9, because you had 8 bits plus the parity bit to make sure that everything was in fact legit. Okay, if we couldn't even agree on that today, right? What's the size of an integer? This is something that the C++ guys wrestled with for years. Is it 32 bits? Is it 64 bits? Is it something else, right? How should we represent a string? All of these are issues that we would have to agree on. Screw it. Let's create something else that we can agree on, and that something else in that era was XML schema, right? The original schema committee got together because people who were trying to write SOAP couldn't figure out how to serialize objects into an XML format. And so the schema committee came along, and they basically came around and said, yeah, well, forget that problem. We solved a completely different problem. How do I represent XML schema? How do I represent this notion of XML info sets in a XML format, et cetera? How do we define, okay, maybe we don't want to use schema. Maybe we do. I'm not sure. But this concept of we just agree on what we're exchanging, and we don't have to agree on anything else. I don't have to agree that the student type inherits from the person type or any of that other stuff, right? Compatibility based on policy. This was always kind of the vague, not quite sure what this means tenet of SOA. If you walked up to, Don Box or some of these other guys, they were very quick to say, oh, absolutely, right? Compatibility should be based on policy, and policy describes all of those things that aren't an API endpoint, right? What should the security restrictions be? What should the reliability restrictions be? What should all those things be that we have a really hard time agreeing on in terms of code? And they tried to create policy and distill it down into code and didn't go super far. But this idea that we have this notion of policy, that there's this other set of things beyond the API. And fundamentally, if you think about all of this stuff, what they were trying to do, particularly with this stuff around policy, is they were trying to help quantify, they were trying to help codify all of these things that we normally don't think of as programming aspects, right? The IDs. What's its reliability? What's its scalability, right? What's its security? All of these things were things that we wanted to try to capture because they're important somehow. This is not something that we ever really saw before with any of these other technologies. What we were really trying to do, I assert, is that we're trying to build platforms. If you look at all of these different technologies across history, where we've been the most successful is where we have actually defined a platform. because this somehow gives it a degree of tangibility that some of that other stuff on its own just didn't seem to. And if we don't think about it from a platform mindset, and I'll explain what that means in a second, but if we don't think about it from that mindset, then it just kind of feels like it's random technology jumbled together, and it usually doesn't work anywhere near as well as a platform does. From a sort of a frou-frou marketing perspective, right, I think platform-oriented architecture is the logical successor to SOA and REST. But the interesting thing is it's also kind of the ancestor to all of this stuff. We've had platforms for years. Anybody who's ever worked in this industry, if you've ever taken a job interview, if you've ever walked onto the new project, the first thing you ask is, what platform does this run on? This notion of platform, it's kind of an intrinsic one, but if I ask you to define it, we start getting into very different definitions. It's very Potter Stewart-esque, right? This is the US Supreme Court judge who, when asked to define pornography, said, I cannot give a definition, but I know it when I see it, right? Same thing with this stuff. I can't give you a definition of a platform, but I know it when I see it. Well, I'm going to try to give us a definition here in just a second. But what we do know is that a platform is typically a core component of the operating system, right? We talk about the Win32 platform. We talk about the COM platform, the .NET platform. It's a core component. We know it's there. The Java platform. We also tend to use the term that it's not tied to a particular OS or language or database, right? So if I say, hey, the Java platform, it runs on all these different operating systems. It runs on all, the Java environment actually has multiple languages that run on top of the Java platform. And it's more than just a virtual machine, right? There's typically some libraries and some other stuff associated with it. The .NET platform now is also not tied to Windows. Right? It actually never was. That's why it's an ECMA standard. Thank you, Mono, for going out there and blazing that particular trail to prove to people that .NET wasn't tied to Windows even from the very beginning. And a lot of times, when we think about platforms, there's usually a component of distribution here. But again, even if we go back through history, the C language is a platform. And that's clearly not a distributed platform. It is still a platform. It's a native platform. And it has certain implications, it has certain rules, et cetera. So it's kind of this vague amorphous thing, which I'm going to try to get a little bit more concrete here. Specifically, it's these three things. A, it's focused principally on developers. Now, one of the things that the RESTful guys will stand up and say is that this is the way that the web works and therefore it's a good thing, except a lot of times when we talk about REST and we talk about how you build RESTful systems, inevitably we run into hypertext as the engine of application state. And if you were here for the panel discussion last night, we talked about, I gave the example of Dell and their initial online store and keeping the price in a hidden form field, and sometimes that's not the best place for state. So I would actually stand up and say, what Roy Fielding built was good, but it wasn't the last architectural style we will ever need. And particularly if you look across the web today at the things that people are building, at the new platforms that people are constructing, that's not really the manner in which they're doing it. They're doing a web API, which is not the same thing as REST, but these web APIs, they're not consumed by consumers. Nobody that I know of who's not a developer walks up to the meetup.com API and directly consumes the JSON. Instead, there's something else that consumes that for them, typically some sort of single-page application, et cetera, some sort of web service, some sort of back-end service that's consuming that, et cetera. Platforms are developer-focused. So if we're thinking about what do I present to the consumers, well, that's not actually a part of this conversation. You as a developer may build a thing for the consumers that in turn runs on or uses a particular platform. But it's not aimed at the consumers themselves. But the other thing that I think is really important here is it's tied to a particular domain. And please, there's a difference between domain and domain-driven design. I'm not getting into the DDD stuff yet. It's just tied to a particular concept. Meetup.com is a platform specifically for creating meetings, meetups, people who want to get together and talk about a particular subject. If you want to find a restaurant, that's not what meetup.com does. Salesforce.com is a platform, and they are specifically geared around CRM. And if you want to do something that's kind of well outside the CRM domain, Salesforce.com won't help you. Platforms are tied to a particular domain. Now, I have to be careful here because I just used a whole bunch of examples around operating system and programming language and so forth. Yeah, those are a slightly different variation of platform. I could kind of stretch it and say, well, yes, the Windows platform, the domain is running Windows code, which kind of becomes a tautology. I have to be careful there. But unless you're in the business of creating a new operating system anyway, I don't know that that definition, I don't know that we want to be held specifically to operating systems as the example, which is why I throw out Meetup, I throw out Yelp, I throw Salesforce, all of these new platforms, the ones that are starting to emerge and starting to gather a lot of steam and momentum, the API revolution that we're hearing about coming out of San Francisco, et cetera. That's really where I want to go. I want domain. I want it to be related to a particular space. If you work for a company, your company implicitly has a domain. And in some cases, your company has many domains. In most cases, your company has many domains. There's the domain that you sell to other people, right? I work for Widget Corp. We sell widgets. Great, but you also do HR. You also do some level of manufacturing. You also do some level of e-commerce. Each of those can be domains within the larger domain of selling widgets. Domain is deliberately kind of amorphous here. When you stand up a project, that's going to be one of the first things you have to figure out is what is the domain we're trying to solve. You're going to figure that out anyway once you start moving down into more of that DDD stuff. But you got to know, you're tying this specifically to a domain. The lastly is this notion that it shares an execution context. If you go look up the definition of context, you get a very, very amorphous discussion, and we'll get to that in a second, because I think in many respects that becomes the real heart of the whole thing. The problem is if I give you just that previous slide and walk away, you're left with this, okay, I've got this abstract notion, but I don't have any concrete technical details. So, platform-oriented architecture means a communication backplane of some form. Right now, the RESTful guys will stand up and tell you that the only communication backplane is HTTP. What's that? That sounds like what? Atom, A-T-O-M? Yeah, the RSS feed or whatever, yeah. A communication backplane, but it doesn't have to be a distributed communication backplane. Again, if I have the C API as an example here, the communication backplane there was how do we exchange stuff across a call stack, right? That is technically a communication backplane. The foreign function interface, the C interface, is a well-known communication backplane for allowing different languages to talk to one another. It's well understood. We know how to lay these things down across the stack. We know where the results are going to be, et cetera. We just have to agree on how to talk to one another. And notice that this, in turn, opens this up in a way that a lot of this discussion you might not have thought of. If I stand up and say, I am building a platform and I am building it on top of a messaging system, that is by itself a communication backplane. We have to agree on the ins and outs. We have to agree on the communication style. We'll have to spend a little bit more time defining that because there isn't necessarily a well-defined set of messages that everybody agrees to. So we'll have to figure out what those messages will look like. And this is where things like XML and so forth became very helpful because they had a slew of tools that would allow us to help define that very clearly. Here is the schema. This is what I'm giving you. Here is the schema. This is what you give back to me. Here is the JSON LD that describes the JSON that I will give you. Here's the JSON LD that comes back. Here is the semantic web RDF definitions of triplets, tuples. This is what I'm going to expect us to communicate in. Whatever that is. As long as you understand the channel by which we communicate and the stuff we are exchanging, which gets us to the second set, the entity set or definition. I'm deliberately staying away from the term domain model because as soon as I say that, everybody goes objects because we are all well-trained programmers. And we all have been trained over the last 20 years that anytime somebody says the word domain model, you immediately think of DDD-style objects. We want to have a rich object model. And the functional guys have no idea what you're talking about. All that stuff that we heard yesterday about actor model and akka and so forth, all of that was done in a language that didn't have objects at all. Didn't even have anything remotely resembling them. They had tuples, bunch of fields just sort of arranged in an unnamed blob there, but that's the closest they get. And they've been wildly successful. You don't need objects here, but we do need to agree on, and so what term do I use instead of objects or domain model? Entities. We have to agree on the things that we're shipping back and forth. When I say to you that this domain is around selling products because it's an e-commerce domain, I have to be able to describe what a product looks like. I have to be able to tell you what attributes are present, etc. Now, how do we do that? Again, I don't really care, right? We can do that either through just sort of an ad hoc fashion. I'm just going to stand in a room with you, we're going to scribble it on a whiteboard, everybody takes notes, and we go back, right? That's one way to describe it. Or we can get very, very formalistic and create a language to describe this via metadata, right? XML schema and what have you. But we have to define that entity set that we are going to communicate back and forth to one another. There's also an agent model because these things don't exist in a vacuum. There's going to be actors, whether they are human beings or whether they are systems or some combination thereof. There needs to be this recognition that there is an actor, and certain actors will be permitted to do things and certain actors won't. And so how do we specify that? Lastly, this is what the services guys, I would argue, would refer to as the policy, right? The set of expectations. When I do this, when I send you a message, what happens? Traditional messaging middleware suggests that once I fire that message off, I'm done. I can go on and resume my day, right? I'm finished. But we built all of this layer of infrastructure on top of everything to say, well, no, what I really want to do is I really want to block and wait for that message to return because that's an easier programming model for most of the people who are programming from the client side. That's basically how RPC came to be. So whether you want to do this in terms of a synchronous versus asynchronous conversation, I don't really care, right? Just as long as we agree on what that exchange will be like, on if I send this to you and I don't get a response right away, does that mean you're down? Does that mean that the network is simply slow? What's the expectation here around performance? If all of a sudden I get 15,000, can I just flood you with requests? If all of a sudden I get lots of clients, can I just throw these things at you as fast as I possibly can, and I can expect you to be able to handle that? Will you scale? What is the appropriate level of scale? And if something goes wrong, how will I know it? How will you signal that to me? If you look at any of these platforms, ranging anywhere from the operating system all the way up through the latest and greatest web APIs, they all have to agree on this in some fashion. And some will say, in order to best support your bulk needs, we will provide you a batching API, right? Here is a particular endpoint where you can just send 15 or 100, but usually there's a limit somewhere of these requests, and we will be able to handle them all, and then we will tell you how each one responds, et cetera, et cetera, et cetera. There's got to be this agreement. There's got to be this understanding of context. This is the thing in many respects that I think is missing from most of the web API discussions. It's sort of implicit. It's sort of understood. There's going to be some conversation around context. And so one of the things I was doing is I've kind of gone back and said, well, what is context? What exactly does that mean? We will frequently toss it around as developers, right? We will talk about an execution context. The COM guys explicitly referred to context. Your COM component was always executing within a particular context. Circumstances that form the setting for an event, statement, or idea, and in terms of which it can be fully understood. Whoops, sorry about the typo there. That's the Oxford English Dictionary definition. I happen to be something of an amateur philosopher, so I went to the Dictionary of Philosophy. Some total of meanings that are A, intimately related to a thing, B, provide the origins for, and C, influence our attitudes, perspectives, judgments, and knowledge of that thing. I'm going to go back to the whole election cycle, right? It is perfectly reasonable for you and I to discuss our respective political beliefs over beer in a bar, but not in a meeting with a VP. The context there matters. And that's one of those things that we sometimes lose sight of because it's so implicit. Context matters. You see this all the time in debates, right? Or flame wars, etc. Two guys are arguing with each other on online forum, right? N-Service Bus rocks, N-Service Bus sucks. They're rah, 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 rah. Okay, are they talking about the same thing? I mean, one guy says that it totally doesn't scale and it totally doesn't work and blah, blah, blah. And the other guy says, oh, it's amazing, you're just an idiot. And then you start drilling in. If you actually have the opportunity and you start probing at what their experience is and why one of them says it's great and one of them says it's terrible, you start discovering that they are using them in very different contexts. One of them wants to use it on a mobile phone. The other wants to use it in an enterprise scenario. And all of a sudden, and I don't mean they want to be a client to the service bus, they want to run the actual N-Service Bus on the phone because reasons. And you're like, okay, now I begin to understand, right? You can see the same argument stretching all the way back to the relational database arguments of the 70s. If you try to stand up Oracle 5 on a mobile device, it probably won't work very well either, right? Context matters. And in particular, there's an O'Reilly book that I just discovered recently called Understanding Context. And here, this guy's talking more about UI, UX, but he's got a really good, succinct definition. An agent's understanding of the relationships between the elements of the agent's environment. In other words, we have these things, agents, we have some sort of understanding, relationship between the elements and the environment in which all of this is happening. Right? This is sort of the abstract principles that will help define that platform beyond some of those technical details. And so, what we want to do in many respects is we want to try to explicitly define this context as much as we reasonably can. Again, if we can do it in technical details, that's great. But if we can't, even just you and me sitting down and talking about it out loud, that's better than nothing else, just sort of assuming. When we look at a lot of these failed technology systems, it's because we didn't understand the context. Distributed objects, we didn't understand the costs of doing things across the network. So for example, if you're going to build a platform, I think you do these 6 steps, right? A, we have to swag out what those requirements are, right? And I'm not saying we have to like decide everything up front. I'm thinking like an afternoon. You sit down with the target market, you sit down with the users, you sit down with the marketing guys, etc. What exactly do we need to build? What is the domain? What are we trying to create? How far does it need to reach? If I am trying to build a consumer-facing system, if I'm trying to build Yelp, then obviously it needs to reach out to all of the different things that consumers might want to consume Yelp from, which basically means the mobile device space, no question. If I'm trying to build the HR system for the company, this really only needs to go as far as the company borders. Doesn't need to go much further than that, and that's totally acceptable. I don't necessarily want it to go out beyond that because of all the security implications, et cetera. This is going to be important when we get into the communication discussion next, because that'll help drive what communication backplane we use. How fast does it need to be? How much of it do we need, et cetera, et cetera? Yeah. Well, aside from the fact that it doesn't have a really fancy acronym, and I'm not really holding myself to any particular, format. Again, the swag, right? Stupid, wild ass guess, right? I just need to have, if we're talking about scalability, I just need to have an order of magnitude discussion, right? How many users do we think we're going to have in the first couple of years? Is it 1, 10, 100,000, 10,000, et cetera, right? If we're going to have a performance discussion, really, it's, okay, is this expected to return within the same time frame as the user issued the request, right? Or is this intended to deliberately be a I send it and I walk away kind of scenario? We just need to have some basic rough framing of this, whereas, ATAM tends to be much more formalized, right? At least that's the concept I've always heard it, is these guys in suits standing up on stages, application trade-off, application model, architecture model. If it's got an acronym, it's more formalized, period, right? I mean, we won't even get into UML, right? Wasn't until UML got an acronym that all of a sudden we had like 12 different diagram types in UML. Or is it up to 15 now? It's kind of silly. All of these things are things that we just need to lay out in very, very casual numbers, right? How broadly do we need to reach, right? How interoperable do we need to be? Am I expecting clients from Java to be able to consume this, right? So how far do I need to go, right? I need to decide what my implementation set will be. This is basically so that we can know what we're going to write code in. It's not critical to the platform itself, because the platform, ideally, the communication backplane, that will be how we talk to one another. Whether that's messaging, or whether that's HTTP, or whether that's the C foreign function interface, I don't care. And so here, this is where I think this is just basically an implementation detail that the rest of the world shouldn't care about. The communication backplane, oops, I got cut off a little bit there at the bottom, right? How much reach, what are the channels I want to use, et cetera. Again, everybody loves HTTP. There's a lot of reasons to love it. One of the basic reasons not to love it, client-initiated request response. Client always has to start the conversation. What if I want to start it and push it out the other way? Define the entity models. What are we exchanging? Again, kind of, however you want to specify that. Just be very careful that however we define it, the very next question that every developer will ask is, how can I create code around this? How can I code gen this? It's happening in the web API space. Everybody said we're going to exchange JSON, and immediately people started working on a JSON format to do code generation. Now we have Swagger, and we have RAML, and we have all these other languages so that people can do code gen based on these specifications. Who are the actors? How do they establish themselves? And then you build out a DevOps pipeline. Again, this is basically an implementation detail. Your clients, the other members of the platform, the people who will consume the platform, they won't care about this, but you will. Because immediately you're going to start dealing with deployment issues, and you're going to start dealing with versioning issues, which we have to deal with from the very beginning. That's one of the things we learned from the services space. Everything else, I don't care about. I really don't. You want to run it in the cloud? Great. You want to use containers? Great. You want to use a functional language? Fine. You want to use an object language? Who cares? These are all implementation details. They don't leak beyond the border of the service, beyond the border of the platform. I, as the consumer of that platform, should not care. Only you, the producer of that platform, should care. The platform stuff, I don't know. I'll be very blunt. I don't know. This is just what I believe. This is kind of what I'm intuitively feeling. This is kind of what I've been building in the last couple of years as I work with clients and so forth, slowly evolving this notion of platform out, right? It's sort of related to services. It's kind of not. It's sort of related to REST, but it's kind of not. I'm picking and choosing these different elements from different places and throwing it into the mix and saying, will it work? We've seen lots of platforms, and we've seen lots of platforms be successful, and we keep using that term. That is one of those terms that has existed since the 80s and is going to continue to exist well into the 2020s and beyond. So part of what I'm looking at is, if that's one of the only terms that has stretched across that entire length of time in casual conversation amongst developers, what platform are you on? This tells me that there is something here, and it's something successful, and we want to tap into it. And this, I think, is what's going to allow us to build these things successfully in the years to come. But who knows? NSBCon 2020, I may stand up here and say, you remember all that platform shit? Sorry. Thanks, guys.